The first chapter of Acc Precalc reviews different topics from Algebra 1 and Algebra 2. This first section focuses on two parts. One, solving a system of linear equations, and number two, finding the distance and midpoint between 2 points. So let's take an example such as the system of equations 3x minus y equals 9 and x plus y equals 3. Remember, a system of equations is nothing more than more one equations combined. We want to find what these two have in common. There are three methods that we'll use in this class. The first method is graphing. To graph it, I'm going to convert both of them to slope-intercept form. So in equation 1, if I solve for y, we get y equals 3x minus 9. In equation 2, we get y equals negative x plus 3. As a reminder, these are the y-intercepts, and these are the slopes. So if we graph this on a coordinate plane, the first equation would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'd go up 3 over 1. The second equation would start at plus 3 and go down 1 over 1. This intersection point represents the solution, and it appears to be the point 3, 0. Obviously, the limitation of graphing is that it doesn't provide the accuracy that we're going to need in this year of study. The important part will be that actually when we get into the school year, take these two equations, put them on the calculator, and solve the intersection that way, which will give us a better estimate if the intersection is going to be something nasty like a decimal or irrational number. The second method is linear combination, or what some people call elimination. On this method, you basically take the one and add it to the other or subtract it to the other with the goal of canceling one of them out. I notice that the y's are opposite signs, so all I have to do is real quickly add these two numbers together, or add these two equations together. 3x plus x gives us 4x. The y's cancel. 9 plus 3 is 12, so x equals 3. I can then take that and plug it back into either one of the equations. This one's easier. So 3 plus y equals 3, so y is equal to 0. Obviously, if none of them cancel out right away, we can multiply one of the equations by some sort of number or scalar, and that would allow us to then add or subtract to cancel something out. The third method is substitution. This is the method that I feel most students are most comfortable with. And that is, we can solve for y in one of them. I'm going to solve for y in the second one since it looks the easiest. So we get negative x plus 3. I then take that and sub it into the other one, where the y is. So you can see I left a blank. This is where y is supposed to be. So I plug in negative x plus 3. When I distribute this minus sign, we get 3x plus x minus 3 equals 9. So 4x is equal to 12. Therefore, x is equal to 3. And again, y then would be equal to 0 when we plug it back in. To summarize what we just did, there are three methods of solving systems. 1, graphing. And again, when we get back to school after the summer, we'll focus more on how to use the calculator for this. 2, elimination or linear combination. 3, substitution. When we're solving a system of linear equations, there are 3 possibilities for your answers. One, they could intersect at one point. That is the most common, obviously, which we saw in this last example. 2, there could be no solution. This is where the lines are parallel. And 3, you could have an infinite amount of solutions. In other words, you have the same line. Usually you can tell these two by how it solves. So for instance, you'll often get a 0 equals 0 or a 0 equals 1. If it is true, it would be the infinite solutions. If it is false, it would be the no solutions. That's usually how it appears when solving a problem. The last quick concept I want to go over is how to find distance and midpoint. Let's use one quick example to derive these formulas, because I find a lot of people have trouble memorizing these formulas, and one goal of this year is for me to get you guys not to memorize but to actually think about where these formulas come from. If we take the point, if we let A be the point 2, 1, and let's let B be the point 3, 2, and we graph this, there's A, and B would be 3, 2. In reality, the distance formula is nothing more than this right triangle, or Pythagorean theorem, where we have the x distance, the y distance, and then you'd have c. So in reality, the distance formula is nothing more than x squared plus y squared equals c squared. And we often write that as the distance equals the square root. So in other words, we're solving for c, the square root of the differences of the x's, the differences of the y's. Or in other words, the length in the x direction, the length in the y direction. So in this example, the distance would equal the square root of 3 minus 2 squared plus 2 minus 1 squared, which is equal to 1 plus 1, which is the square root of 2. The midpoint, on the other hand, is actually so much easier than what people make this out to be. How do you find the middle of something? You find the average. And for that reason, you just simply take x1 plus x2 and divide it by 2. It is simply the average of the x's. And then you have y1 plus y2 over 2, the average of the y's. So in this example, we take the x's and do 2 plus 3 divided by 2. So it's 5 halves. For the y direction, we have 1 plus 2 divided by 2. We have 3 halves. So our midpoint is 5 halves, comma 3 halves. That wraps things up for section 1.1. When you return to school, we will do some of the harder problems involving perpendicular bisectors and things of that nature. But this is the foundation. You should now be able to complete section 1.1 of the take-home assignment.